So do you have any feedback from last week? I will share my screen with you. But, yes, today, in fact, we try to cover some topics which are. But I just try to move this one here. Maybe it was important to just share first. Okay. So can you see my screen now?
Yep.
Okay. So today, in fact, we need to cover. I mean, last time we started by a perceptron. We go to this. We try to talk about, maybe this is not the. Maybe I need to get this one here. I hope that it's much better now. So it should be better now. So in fact, today we need to cover important tasks. I mean, last time we have been talking about a perceptron and a perceptron learning rule, and we used it for solving some problems. Today also we will explore a very important library in Python. It's called sklearn. So sklearn, it's a very important one. We need to talk about it because this tool is very important in Python and we need to use it. We will go back to iris classification problem. I mean, we did that last time, but we will repeat it today, but using sklearn. I mean, last time we implemented our perceptron, if you can remember. So we studied perceptron and we studied perceptron learning rule. We started also this adaptive linear unit, but today we will try to implement a perceptron using sklearn. Sklearn, it's a very nice tool, and it's a very important tool in machine learning, and we need to know how to use it. The perceptron, we used it for binary classification. So we will use iris. I mean, we know iris classification problem. Iris dataset, it has 3 classes. So we will extract the first 2 classes, and we will solve the problem for the first 2 classes as a binary classification problem. And we will plot the decision boundary. It's very important to understand how the decision boundary looks like. It's a decision line, so we need to know how to plot it. Also, before testing and before training our data, it's important to split the data into a training and testing. Very, very important. So this step is very important, and we need to use it to be sure that when we train a model, we will have enough data for testing it. And those data, it should be never seen before for the model. So it should be brand new data where we can test the model, because when we build a system, we need to be sure that the system is working. So we cannot test it with a data from the training set, but we need to split the data at the beginning into a training and a testing set. What if we have multi-class classification problem? So multi-class classification problems like iris dataset, we have 3 classes. It's not yes and no, it's not binary classification, but we have 3 classes, right? So in this case, we need to know how to extend a perceptron for multi-class classification. I mean, perceptron, you know that we use it for binary classification, but But if we have multi-class classification problem, so we need to know how to extend the perceptron for solving it. We will explore a method which is very simple one. It's called one versus rest, OVR, one versus rest. And one versus rest approach, it's very simple. If we have three classes, we will develop a perceptron to classify one class against the rest of the whole dataset, against the two other classes, and we will repeat this one for the three classes. So at the end, we will get three perceptrons, one for each class. We need to know something called logistic regression. Logistic regression, it's a perceptron also. I mean, a perceptron, we have the activation function, unit step activation function, but in case of logistic regression classifier, it's called logistic regression, but it's a classifier, not regression, in fact. So we will replace the binary activation function with regression function or with Gaussian function. So it's just a matter of the activation functions. In case of activation function using a Gaussian activation function, the output in this case will be probability. But in case of a perceptron, it will be just 1 and 0 or 1 and -1. So it could be, it's just class A and class B. But in case of logistic regression, the output will be probability. Probability is that this data point belongs to this class. And of course, the summation of probability should be 1, for example. So you will have to, I mean, it's just a probability. So it will be, for example, 0.6 is that this data set belongs to this class. So the other one will be 0.4, right? Because the summation should be 1. We need to use logistic regression for iris dataset, right? Because in iris dataset we can solve it as a binary classification problem. In this case, we will pick the first 100 data points, and in this case we will have two classes. And if you want to extend it for also multi-class classification, it should be fine. So we will use this one versus rest approach. One versus rest approach, you don't need to worry about it. You can implement it by yourself, but also it's something implemented in sklearn. But the idea or the concept is quite simple. I have three classes, so I will build a model to classify one against the rest, and I will repeat this process for the number of classes which we have. So at the end, we will have n perceptrons or n models, one for each class. We need to know what is separable and inseparable data sets, because in linear regression, for example, it's important that my data sets is linearly separable. Linearly separable means we can draw a straight line, and this line can be used for classifying our data set. Confusion matrix. So after building your model, you need to test your model. Is it performing fine? So how can we do this? We need to test the performance of our model. And in this case, we will use something called the confusion matrix. So we will study terms and the definitions of the confusion matrix, and how can we implement confusion matrix in sklearn. Quite simple. It's just one line code. And after that, if we have time, we will go to multi-layer neural network, multi-layer perceptron classifier in sklearn. How can we implement it in sklearn? How can we implement MLP classifier in Keras? For example, Keras is a fantastic tool, and we will use it a lot. If you will study deep learning, for example, you need to know how to use Keras. It's simple. It makes life much easy. So for us, in this course, we have, the first part, it should be neural network. So maybe we can continue for 1 or 2 weeks more. Studying and solving examples and try to use some data pre-processing techniques. So maybe we will not learn new stuff, maybe from next week, for example. But we need to spend the time and know how to use those tools just to prepare you for your project. Because in your project, maybe you will be subjected for, you need to work with data, you need to build a model for classifications, for regression. So it's important to know this knowledge and to get the skills which will help you to go forward in your project. It's just the start, and after that, you will be autonomous, you will be able to work by yourself. So sklearn, it's Python machine learning library offering a vast collection of machine learning algorithms for data processing, model selection, model training, fine-tuning, and evaluations. It's a fantastic tool, and it's easy to use. So from a point of view, it's much easier than working with MATLAB, because we need to learn really how to work with Python instead of working with MATLAB. Last year we have been working with MATLAB, but MATLAB is expensive and you need license. And at the end also, if maybe it's for prototyping, But if you want to build a system which can be implemented in a robot, for example, you need to work with Python. So Iris dataset, we studied it last time, but we can talk again about Iris dataset and Iris dataset classification problem. We have a dataset, and this dataset consists of 150 data points. And each data point consists of 4 features. Those 4 features are the sepal length, sepal width, petal length, and petal width. And so A, B, C, and D column, we call them input features. So this one we call it input feature. So we can call it, those are the features which will be used for input features. Those are the features which will be used for the classification problem, and those numbers, it's number between maybe 0 and 10, for example, or maybe 0.1 and 10, or whatever. And finally, we have the last column, and this last column we call it T, for example, or target feature. So we can call it target feature or labels, target features or labels. And this last column, it has 3 different classes. It's Setosa, Versicolor, and Virginica. So we have 3 classes. We have 3 different types of flower. So using the petal and sepal length and width, we can classify it into 3 different classes. So if you want to build a model, it's a simple. We need to build a model. So if I want to build a feed-forward neural network, so I can just select the hidden layer, for example, how many units in the hidden layers. And for the input layer, we will have 4 inputs, right? So we will have x1. I will just call sepal length x1, x2, x3, and x4. Just make those connections, and the output layer, we will have 2 outputs, right? No, 3. We can just have 3, for example. So in this case, we will have 3. So 1 for each class, for example. So we can build a neural network like this one. So today we will try. I mean, if I need to solve this one using a perceptron, how should we do? We just select I want to plot it in 2-dimensional space. So if you want to plot it in 2-dimensional space, maybe you need to select 2 features. So you can just select AP or AC, AD, BC, CD. You can just select 2 columns or 2 features. And we will select the first 100 data points, because the first 100 data points belongs to the first 2 classes. We have here 3 classes. So the first 50, it's Setosa. The second 50, it's Versicolor. The third 50, it's for Virginica. So we have 3 types of flowers. And if you want to solve it using a perceptron, in this case, we need to convert the problem into binary classification problem. So binary classification problem, which means the output will be 1 and 0. So I can just select, okay, this Setosa, for example, I will call it 0, for example, right? And the other one, I will call it 1. So now we can solve the problem as a binary classification problem using a simple perceptron. And in the perceptron, we will train it using PLR, perceptron learning rule, and the activation function, of course, it will be step function. So if you can open your this file, it's called the perceptron iris SCI kit. So this file, if you can open this file in your Colab, you can just go through it with me, please. So it's perceptron. So I will explain it, and after that we can go to the code. It's the first part. It's just we implement a perceptron. We need to upload those libraries. So NumPy, sklearn, dataset, because I'm loading Iris here from this dataset. So we have all those datasets, in fact, in those libraries. So don't need to upload files. I mean, last time we have been uploading lots of files, and it takes time and effort, right, from Excel file or whatever. But we need to learn how to do it, because usually when you will be working with your project next semester, for example, you will collect a dataset. You will get those data sets, for example, maybe in Excel file. So we need to know how to read an Excel file and how to visualize the data and plot the data and try to understand how the data look like. So, but in this case today, for example, we will just upload Iris dataset from datasets from sklearn, and we will import a perceptron from sklearn. So sklearn, it belongs to linear regression, and we will linear model. I got some questions. Yes. I will try, okay. Yes. Do you have any question? You can just ask, please, if you have any questions. Okay. Okay, so now you have the file. I can switch also to my code. Thanks, Magnus, because also I need to copy and so I will just open my file here and I will share with you my code. Okay. It's called Iris. Okay, Perceptron. Yes. So it's this one. So now I need to. Can you see my? So this is the code. So the code, it's a symbol. I mean that part just we need to load those stuff, and after that my data set we will get it from load iris, and in this iris x it's the input feature. So we need to select. I'm selecting from 0 to 100, which means we are selecting the first 100 points, and the 2 and the 3 it means petal length and petal width. It means column number 3 and column number 4, right? So in my data set we are selecting. In the feature set, we are selecting the third and fourth column. And for the target, of course, it will be just y equal iris from 0 to 100. And it's already prepared here. So it's all numbers here. I mean, y here, it's numbers between 0 and 1. It's 0, 1, and 2. So classes here are numerical value. We don't need to change it. So it's not text. It's not Setosa, versicolor, Virginica, but it's 0, 1, 0 for Setosa, 1 for versicolor, and 2 for Virginica. So in fact, the data set is very well organized, and we can just use it for training our model directly, right? But remember, last time we talked about standardization and normalization, right? We talk about standardization and normalization. So we need to be careful about this one. I mean, standardization. Anyway, we will run it, and I will discuss about it later on. But it's a simple. Simply it's x minus mean value divided by standard deviation. So I need to get x minus x mean divided by x dot standard deviation. So the equation is simple, and if you want to use this function from sklearn, it's fine. So you can just use standard scalar from sklearn dot preprocessing. It will be okay. But if you don't want to do it like this one, it's quite simple. It will be x equal x minus x mean divided by x standard deviation. So it will be one line code. So finally, we are standardized our data set. Why we standardized it? Because I have a set of features. I have x1, x2, x3, and x4. Maybe they are not in the same scale, and it's important to be within the same scale. So after standardization, all my data will have a mean value of 0 and standard deviation of 1. You can normalize also. When we normalize it, all data points will be between 0 and 1. After that, we will import the model. So the model called the perceptron. How can we get a perceptron? So it's from sklearn.linear model import perceptron. So we will have a perceptron. You can define those numbers here, and you can just ignore it, right? Because there are some default values. So it's maximum max iteration. It's maximum number of epochs for training. The eta, it's eta 0. It's it's a learning rate, random state. And after that, we will train the model fit using x and y. So in fact, here I didn't divide the data into training and testing. We should do this. In fact, we need to learn how to do it. So there is a pipeline for machine learning. We need to follow this pipeline. But here I didn't follow it. I just did it to be quickly. So we need to divide the data at the beginning into testing and training, using the training data set for training my model, and using the testing set for testing my model. And after that, predict and calculate, find the model coefficient, right? So the coefficient, it's omega and b. So I have weights and I have intercept, right? So the decision line will be omega 1 x1 plus omega 2 x2 plus b. Calculating the error value and plotting the decision line, I will explain it. Yes. Okay. So finally, I will run it. I will run my code. So, okay. So those are the weights of my model. So this is omega 1 and this is omega 2. This is the perceptron, the intercept was y-axis, and this is a decision line. So this is we have two classes because I selected the first 100 points. So we have two classes, the blue one and the red one. and this is the decision line. How can we plot the decision line? In fact, it's omega 1 x1 plus omega 2 x2 plus b equals 0. So just substitute the value for omega 1, omega 2, and b, and we can draw the line. And I will explain it how. Here, how can we draw the decision line? I will just switch. But anyway, just run the code, and I will switch to my slides so I can explain it. And yes, so this is my data set, right? This is my data set, and iris equal data set dot load iris, and from 0 to 100, because we are interested in the first 2 classes. So when I select from 0 to 100, we are interested in the first 2 classes. First 2 classes, which is Setosa and versicolor. So now we have Setosa and versicolor. Standardization, the equation for this one, if you don't want to use this one, for example, no problem. The equation is simple, so it will be x equal x minus mean value, or I can just mean of x divided by standard deviation of x. So the equation is simple. So for standardization, if you want to do normalization, so I can just say, okay, x will be x minus x minimum, I can call it x minimum, divided by the range. So the range will be x max minus x minimum. So if you want to do normalization, you can just do it. So just one line, x minus x mean divided by standard deviation of x. If you want to normalize, so x will be x minus x minimum divided by the range of x. The range of x, this one, it's a range. And the range, it's simply the maximum value minus the minimum value. So now we can normalize or we can standardize. We will import our model. Number of iterations, it's the number of epochs, maximum number of epochs for training. This is the learning rate, right? This one, it is a learning rate. And after that model fit, we will just using standardized data. So it will be x standardized and y. Of course, y, we don't need to do anything with y, because values of y, it will be 0 and 1, right? It will be 0 for Setosa, and it will be 1 for versicolor. If you want to predict, sorry, because this one is not correct, so this one also should be replaced by x standard, right? So to make predictions. And if you want to plot the coefficient of your model dot coefficients and the model dot intercept. Those coefficient, it's a vector of 2 elements, because we have 2 inputs. So it will be omega 1 and omega 2. So this one will be omega 1 and omega 2. And the intercept, it's y-intercept, which is b. So now using omega 1 and omega 2, we can plot the decision line. So in fact, our model will be like this one. We have a perceptron. It has 2 inputs. One is x1, one is x2. I'm just selecting. I can select x1, x2, x3, x4, but I used only 2 features. We have a bias here. So this one, it's +1, this one b. So this one connected by omega 1, this one it's connected by omega 2. We have here summation. So the output, we call it net. And after that, I will apply this one to the activation function. The activation function here, it will be this function, right? Step function. So the output will be 0 or 1. So we have 2 classes. So this one will be y. So this is our perceptron. So the decision line here will be simple. It will be net equal omega 1 x1 plus omega 2 x2 plus b equals 0, right? So this is my decision line. So this one will be my decision line. If we want to plot the decision line, I mean in the next graph here, for example. So, but just remember, this is the equation of our decision line, right? So when we have here this green line, so in fact, the equation of this green line will be omega 1 x1 plus omega 2 x2 plus b, correct? Equals 0. And the blue cluster or the blue set above the line, we will call it the positive one. So all values above the line will be positive. All values below the line, it will be negative. So now we can classify our data set into two different sets, and we have a line, and we can just use this line as, I mean, this is our model, this is a decision line. We will keep those weights. So in the future, if you got, so if someone go to the, I mean, he collected a new data, he can just apply those data with this line, and we will see, is it located? So imagine that I got a new point here. So I got a new point here, and I want to know, I know this one, it's Setosa here, it's a Setosa cluster, and this one, it's a versicolor. So we will get a new data point, and this data point, it has two features. One is x1 and one is x2, correct? So I will just simply, I will plot it in the, I mean, this 2D graph, and I will see, is it located above the line or below the line? If it is above the line, it will belong to the blue set. If it is below it, it will belong to the red one, right? Or you can just apply those x1. So it has x1 and x2. Just substitute x1 here and x1 here, right? And if this value is greater than or equal 0, so it will be 1. It will be blue. Otherwise, it will be 0. So it will be red, right? So it's easy. So the decision boundary or the decision line is very important. And at the end, the model will be those weight values. So I have omega 1, omega 2, B. This is our production. So if you are building a model for someone and you want to sell it to someone, you will just give him omega 1, omega 2, and B. This is your model. So the innovation here, in fact, it's omega 1, omega 2, and B. And if you want to use your model, so for example, imagine you are in your bachelor project, you are working, you are building a model for solving some problem, maybe it's machine vision or whatever. So you will have a set of weights, weight value and bias value. So you will have a vector or a matrix. It could be large, it could be small, it could be only 2 values or 3 values. If it is a regression model, you will have omega and B. If it is a binary classification problem, it will be omega 1, omega 2, B, omega 1, omega 2, omega 3, omega 4, B, and so on. So those numbers are the numbers which we need to store. We need to keep those in the, I mean, we need to keep those numbers because this is my model. So for example, if you are building a system and you want to implement it in a mobile phone or Arduino, for example, you will train it in your machine, which is very powerful. And after finishing training and testing and validations and being happy with your results, you just need to keep those small numbers into your Arduino, for example, so it will make decisions later on automatically, right? So this is the decision line. How can we how can we draw the decision line? This one it's x1 and this one it's x2. This is the equation of the line, right? So simply I will just generate points from here to here. This is the range of x1, correct? So I will divide this one into a grid, for example. No, not a grid, just to generate points. So I can just say, okay, x1, it will take some values, right? So it will be, maybe it's -1, -0.9, -0.8, and so on. So I will get x1. Now I want to find what is x2. So I can go to this equation, right? Do you see omega 1 x1 plus omega 2 x2 plus b equals 0? I want to find x2 because I want to plot the green line. So from this equation here, I can just say, okay, x2 equal minus omega 1 x1 plus b divided by omega 2. So now I have x2. So we assume values for x1, right? Substitute into this equation to get x2, and after that I can just plot x1 and x2. So now when we plot x1 and x2, we can get this green line. So x1. So I just generated values for x1 here. I generated values for x. Yes, this is the values which I generated for x1, and I substituted those values into here. I just call it x, x, y, y, but maybe it's not correct. You can just call it x1 and x2, for example, and just substitute those numbers into this equation, because this equation, in fact, it's this one. It's this one, exactly this one. So it's model coefficient 0 divided multiplied by x. So anyway, so this is the one which will generate us the green line. If you want to plot to have fancy plot, for example, in this case, you need to use this mesh grid. So if you have something really very complex, because we will use this approach. If you need to plot the decision region, for example, it will be easy because I know that it's a straight line when it's a perceptron. but when it's a neural network, it will be more complex, right? So in this case, I can just, I know the decision line and I know the range for x1 and x2. So I will have a plot like this one. So this is my plot. I know this is x1, and this is x1, and this is x2, for example. So I will just generate a grid, right? I will generate grid. So I will have all those points here. I will apply the model. So model.predict. So I will x1 first, x1 equal those values, x2 equal those values, and I will use this mesh grid. So when I use mesh grid, I will generate a grid of points. And at each point of those, I will apply my model.predict. I will predict the decision at each point. So using this model.predict, using x1 grid and x2 grid. So I will just do it. So I will get the decision at each point. You can make it small, you can make it much bigger, and after that you will plot it using this contour F, for example. You can use this command for plotting the decision boundary. So it will be like this one. Now we have the decision line. This is our decision line, in fact, and all data points above it, it will belong to this class. All data points below it, it will belong to this class. So you can do it as you want. I mean, there is no, in fact, limit for, I mean, how can you visualize it? It will be great if you can visualize it in a much better way, because it's really, it will be beautiful. And also if you can visualize your weights, it will be really very, very important. So do you have any question for, do you have any question for this example? At the end, I told you it's important to divide your data set into training and testing. Very, very important, because when I trained my model here, I just used the whole data set. I used the whole X and the whole Y for training and testing my model, right? But it's not correct, because we need to train the model and we need to test the model. So we need to hold out a portion of my data for testing my model. Otherwise, people will not, they will not trust my model, because we don't know. Maybe my model overfit my data set. So if it overfit my data set, how can we discover this? We cannot discover this without dividing your data into one part for training and one part for testing. So we can have we can have good evaluation. Of course, we can use also confusion matrix for evaluation, but it's important to divide your data set into a training and testing, so we can understand how the model will behave with a new data set. So when you produce something, you really need to test it. Before deploying it in real life applications. So it's important to divide your data set into test and training. And we have a very nice function also in sklearn. This function called train test split. This function, train test split. How can we get it? We just need to get it from train test split. I guess it's sklearn dot.
You had the import in the other slide.
What?
The import statement is in the other slide. The same slide that you're using it.
Yes. Can you see it? Mm-hmm.
If you go down to page 8.
Mm-hmm. Okay. Yes.
You can see it there at the top.
Model selection. Yes, correct. You are right. So it's sklearn model selection. So we need to import it from sklearn.model selection. You have this train test split. It's simple, and also if you want to implement it by yourself, it's fine. But it's just one line here, and you need to decide here the test size, for example, or the training size. You can have the two options. You can write here test size equal 0.3. You can just write train size equal 0.7. We have also something very nice here. It's called stratify. So this one is very important. Stratify. Why? Because I know that y has two. In fact, y here has two values: 0 values and 1 values. 0, it belongs to one class, and 1, it belongs to another class. It could be 0, 1, 2, 3, 4, and so on. So when you use this option here, stratify equal y, it means we will divide the data set into a training and a testing with balanced data set. So I will have all cases, all classes are represented equally in each set. So I will have So for example, you will have, so for example here, if I didn't use Stratify, so I will have one set which has 14 and another set which has 16. So it will be biased against one of those classes. It will not be balanced. Regarding the classes, all classes will not be represented equally. But when you use Stratify, it will divide the data in a way so that all classes are equally represented in each set. So for example, in the training set here, we will have 35 class 0, 35 class 1. In the testing data set, we will have 15 from class 0 and 15 from class 1. If you didn't use Stratify, it will be something like this one. Maybe we will have 36 class 0 and maybe 34 class 1, 14 class 0 and 16 class 1. And it could be more dangerous, right? So if your data set is small, maybe it will be really very dangerous because maybe some of those classes will not be represented in one of the data sets. So it's important to use this Stratify. Yeah.
If you do the stratification, will it then make the testing and training datasets proportional to what the total dataset is, or will it make them equal?
It's as possible, as much as possible, because sometimes you don't have enough. I mean, maybe in this case we have 50 from class 0 and 50 from class 1, right? So in this case it will be equally. But if it is originally 40 from class 1 and 50 from class 0, for example, so in this case it will try to make it, as much as possible, right? So if your data set is balanced, anyway, our data set was balanced already. We have 50 from class 0 and 50 from class 1. But when we divide it, we need to be sure that we have all classes represented equally in each data set. So in this case, using Stratify or stratification will make this one for sure. But if it is originally not equal, so it will just try to make it's best to make it. All classes should be represented. So in this case, maybe we'll have 30 here and 10 here from class 0, for example, right? So
it'll try and make it proportional instead of trying to make it equal.
Yes. So yeah, it's a proportion. Yes, a proportion of classes will be. So it's important to split your data into training and testing before working with any example. So we need to know this before working. You need to upload your data, try to visualize your data, standardize and normalize your data, for example, and split your data. So remember to split your data into a training and testing. The training part will be used for, training your model. The testing will be used for model evaluation. So yes. So before going to the second point, the second point we will talk about how can we extend a linear model for multi-class classification. So I want you to just take maybe 5 minutes or 10 minutes, run this example and try to see. In this example, I didn't split my data set. So I can just propose for you to just split now and try to run it. And let me know, please, the prediction error for training and testing. So we can have 10 minutes. You have the code already, so just open it and try to modify it, because in the code which I put here, I used the whole X and the whole Y for training and testing. Now, please just split your data into training and testing, and train your model and test your model and find accuracy or prediction error for training and testing. So it's just copy and paste. So we need to copy this block, move this block in front, and try to, instead of using the whole X and the whole Y for training your model, just to try to use, X train and X test, X train and Y train, X train and Y train. We will use it for X train and Y train. We will use it for training, and after that, X test will be used for test for prediction. So we will get Y predict using X test. And if you want to calculate the error, so we need to find the difference or number of cases where Y train not equal to Y predict, for example. So we need to know how many cases in how many examples. We know if we will use this ratio here, 0.3, So we will have 15. I mean, we will have 15 points. So it would be, we need to know how many cases misclassified, how many cases from those 15 are correctly classified, and how many are wrongly classified or misclassified. So we can take, for example, 10 minutes, for example, for, I mean, yes, any questions? I can see some comments. Yes, please. So can you go now to your code and try to run it, and just in the chat write your error, the prediction error for training and prediction error for testing. Because from those two numbers are very important. It will help you to identify if you have overfitting problem or not. So now it's 10:55, so we can start again at 11:10, for example. But please, when you run it, just write here in the chat your results. Thank you very much. Any question in this part before the break? Anyone has any question? Okay, so we will take 10 minutes for coding. As I told you, you need to go back to the code, and I mean, instead of using the whole X and the whole Y for training your model, so this line here, we need to make some changes here, and this one here, right? And we need to calculate the prediction error. Now I have one line here for calculating the prediction error. It's y minus y predict, but y predict for the whole X. So try to get y predict not for the whole X, but for X test. So just make those changes and write in the chat the prediction error for the training and for the testing.